Good morning, students. Today we will discuss the same unit 2, that is knowledge representation. In this knowledge representation, today let us discuss about the structured knowledge representation, that is frames and semantic nets. In the very first class of this knowledge representation, already I have given a brief introduction about this frames and semantic networks. Today in this session, let us discuss in detail how a knowledge can be represented with the help of this semantic nets and the frames. So let us discuss first what is this semantic network. So semantic networks are nothing but these are an alternative to predicate logic as a form of knowledge representation. Here the core idea is to store our knowledge in the form of a graph. We know that a graph means it consists of nodes that represents the objects in the real world and arcs representing the relationship between those objects, and it consists of nodes. Those nodes are also called as the objects or concepts or situations, and arcs are links, nothing but the relationships between them. And its representation mainly consists of two types of relations in this semantic networks. One is the is-a relationship, that we can also call it as an inheritance, and a kind of relationship. So let us see what is that is-a relation and the kind of relation. So when we see these components of a semantic network, so this is one of the simple example of this one semantic network. And coming to this components of semantic network, first we have a lexical part. So in this lexical part, we will be having these nodes, links and the labels. So what are these nodes? These nodes are nothing but the denoting objects, that may be individuals and classes, and the links, we know that the edges are arcs between the two objects, and the labels just denoting the particular objects and the relations. So this is the first component of the semantic network. Then coming to the next one, structural part. So when we have this links and nodes, yes, definitely it forms a directed graph, and the labels are placed on the links and nodes. These labels are going to be placed on the links and the node. And the third one is the semantic part. We know that semantic is nothing but the meanings are associated with this links and node labels, and these details will depend upon the application domain what we choose. And the last one is the procedural part. In this procedural part, we have a constructors and destructors, where the constructors allow the creation of links and nodes, and destructors allow the deletion of that links and nodes. And writers allow the creation and alteration of these labels, and readers can extract answers to those questions. So these are the four parts, that is the components of this semantic networks. And see, this is a small example of this particular semantic network, where we have a relationships over here. These concepts also called as the objects or nodes, and which is not connected to some other things, generally we call them as the individuals. And already told you that nodes are objects and concepts, and arcs are nothing but the relationship between these two objects. And coming to the semantic network, the commonly used links are is-a relationship, that is an instance of, and has a relationship, and a kind of relationship, that simply we can abbreviate it as AKO. Okay, so is-a refers to a specific member of a class. We know the concept of this inheritance, the same thing over here. And has-a links are used to identify the characteristics or attributes of the object nodes, and other arcs like a kind of are used for the definitional purposes. So let us see one by one this with an example. See here how an is-a hierarchy will be. So there is a vehicle, and we know that car is a vehicle, truck is a vehicle, bicycle is a vehicle. We know that this is a parent class and this is a child class. Child is going to inherit the properties from the parent class. So when such relation is there, then we are going to use a is-a relationship. And here the representation and the arrow towards the main class we should be represent. So this arrow towards the base class we should represent. So this is the is-a relationship in a semantic network. And coming to the as-a hierarchy, okay, we know that a vehicle has a brake, vehicle has an engine, and vehicle has a seat. So when we are representing has a relationship, the arrow should be towards downwards to the subclass. So this representation is very important in a as a hierarchy. Okay, and then a kind of, which is also echo. So we know that SUV is a kind of car, sedan a kind of car, and hatchback is a kind of car. So again here, when we are representing a kind of, so that the arrow mark should be upwards. So these are the three types of relationship mainly we use in the semantic networks. Then let us see one example here. these are the some of the statements. Now these statements we should represent in the semantic network. See here, cat is a pet, and there is also one more statement, dog is a pet. So we can say that we can write simply a cat and dog, and both we can represent is a pet. We know that is a relationship. So is a relationship should come downwards, something like this. See, cat is a relationship and dog is a relationship. Both are pets. And then next, cat has a tail, dog has a tail. It is has a relationship. So when we have a has a relationship, we know that cat has a tail and dog has a tail. Okay. Similarly, cat likes to eat fish and fish lives in water. So we can combine these two statements in a network, that is, see, cat likes fish and fish lives in water. Okay. And the last statement is here, dog likes to eat bones. So it is only single statement, so directly we can relate dog likes bone in this way. So this is one of the example of this semantic network. Let us see one more example. So these are the some of the statements, like Moti is a dog, Moti is a mammal, Moti is owned by Nakita, Moti is white colored, and all mammals are animals. See here, we can relate here, Moti is a dog, and we know that dog is a mammal, and we know that all mammals are animals. Means we can combine these three statements. We can have a link between these three statements. See here, Moti is a dog, dog is a mammals, and all mammals are the animals. And these two are different, that Moti is owned by Nakita and Moti is colored white. So in this way, these particular statements are going to be represented with the help of a semantic network. And just read this particular statement. Okay. And this statement, given this statement, now we have to represent this particular statement with the help of a semantic network. See here, every human, animal and bird is living thing, all birds can fly, men and women are humans who have two legs. Okay. See, let us see the representation of this semantic network. See here, we know that man is a human, woman is a human, and human has two legs. So we can make it as a separate property. And if you want to mention some name, John is an instance of a man. Yes, it is an instance of man. Then human, animal and bird, these three are living things. So we kept here a relationship as a is a relationship. Okay. And giraffe is an instance of animal, and cat is an animal. So parrot is an instance of bird, and see here, parrot is a bird and is in green color. That's why we have added another one. And we also have a statement like cat is animal and has a fur. Only cat is having that one. So we have written here a separate property like cat has fur. And all birds can fly. So only birds can fly. That's why we had a separate property that bird can have a fly. Okay. And then living thing, the other properties is they can breathe and they can eat. So the overall this particular sentence is represented with the help of this semantic network, where we are connecting nodes, connecting with the relationships, and we are using is a relationship and has a relationship like properties. Okay, this is how we are going to represent one particular problem with the help of a semantic networks. And coming to the advantages and disadvantages of this semantic networks. So semantic networks are natural representation of this knowledge. They convey meaning in a transparent manner, and these networks are simple and understandable. But coming to the disadvantage of this particular semantic network, it takes more computational time at runtime. Why? Because we need to traverse the complete network tree to answer some of the questions. And they are try to model like human memory, okay, where human has 1015 neurons and links to store that in information, but coming to in practice, it's not possible to build such a vast semantic network. Okay. Next one, knowledge representation using frames. So these frames are more structured form of packaging knowledge, and it is used for representing objects and concepts. And here mainly this we are going to have a hierarchy format of these frames, and where lower level frames can inherit information from the upper level frames. So here the important components of this frames are a kind of or this subclass. Like you can take an example like a science faculty class is a kind of faculty class. Okay, is a instance, like connecting a particular instance of a class frame, that is some faculty X is a science faculty and a part of, we can say that CSE department is a part of college. Okay, some or else one class, faculty class is a part of department class. So in this way, these all nodes of one frame to other frame are connected with the help of all these components. Okay, now see, each frame may have any number of slots needed to describe a particular object. Okay, like faculty name may have name, age, address, qualification. These are all nothing but the slot names. And each frame includes mainly two basic elements, that is slots and facets. And each slot, these slots may contain one or more facets. We also call them as the fillers, which may take many forms such as value of the slot, default, there will be default value of the slot, range, like if you want to range suppose a faculty, the range of age should be some 25 to 45. In such cases we can make use of this range. And demands, like such as if you want to add, if you want to delete something extra you want to add, we can make use of this one. And others may contain some rules, other frames like semantic network or any other type of information. If you want to keep it in a frame, we can keep that. So this is what the components of this particular frame are, two basic elements of the slots and the facets. So this is an example of a frame network. See here how is one frame is interconnected to another one. So starting from here, you see Renuka is one of a faculty. Renuka is a science faculty. Science faculty is a kind of faculty, and we know that the faculty is a part of department and department is a part of university. How they are interconnected, you see. And in the same way, there is one hostel named some Nilgiri hostel is a hostel, and hostel is also a part of university. In this way, so each one we are making it as a frame and we are interconnecting each and every frame. Okay. So if we describe with the help of slots and facets how this particular frame will look like is, see here, the same one. So detailed representation of this frame network. Let us start this frame first as 0, where in this the slot values are like, if you are taking about university, this frame name is university. Yes, phone and address we will have a default values, so that's why we have written a default value. Next, each university will have a department and university will also have a hostel, that we named it as frame 1 and frame 2. See here again the frame name is department, and a part of, this is a part of, yes, frame 0, and what programs a particular department is going to, this university is, each department is BTech, MTech, PhD, such program. And then next one we have named the frame as 1-1. Here we are in a department, we are going to have a faculty, so that faculty name and is a part of this frame 1. Age, yes, I already told you. Range, if you want to mention, you can mention here. Nationality default and qualification default, they should have a postgraduate. And here I have created one more frame with a name 1-2. Here I want to mention some subject faculty. So faculty name is science faculty, a kind of, yes, faculty, and qualification default, yes, if you are a science faculty, compulsory you should have a MSc physics. Like that we are going to write the slot values. And here I want to mention some name of this particular faculty. So again I am creating one more frame 1-2 here, 1-3. That faculty name is Renuka and is a science faculty. Instead of writing again science faculty, just we are representing with frame 1-2, and the qualification, yes, PhD, age and address. So in this way we are interconnecting to the main frame. Okay, and coming to this side, frame 2, so frame name is hostel and is a part of frame 0. Room default some 100 rooms. Okay, then frame 2, next one is frame 2-1, we have to name it as, name is, the particular hostel name is Nilgiri and is a frame 2, that is a hostel, and the phone number, the slot value of phone number is something like this. So this is what the detailed representation of a particular frame network. And coming to this advantages and disadvantages of this frame representation, it actually makes the program easier by grouping the related data, and it's very easy to add slots for new attributes and relations. Why? Because as we are creating the frame, so we can add any number of slots, and then it is easy to include the default data and search for missing values. and it is easy, frame representation is easy to understand and visualize. But coming to this disadvantages of frame representation, this inference mechanism is not be easily processed. That is one of the disadvantage of this frame, okay. And inference mechanism cannot be smoothly processed by the frame representation. This is what the minor disadvantage of this one, okay. So this is what about the structured representation using this semantic network and the frames. Thank you.